Eliminating anomalies is a critical task to enhance machine reliability. The autonomous maintenance methodology was developed by JIPM with the understanding that, firstly, it's essential to restore the basic conditions of the equipment. This involves removing all types of anomalies and defects, thereby addressing accumulated deterioration and preparing the machinery for more productive preventive maintenance tasks. This lesson introduces the 7 types of anomalies recommended by JIPM experts. Standardizing anomalies into categories simplifies training of operators, recording their information, and managing the planned activities for their complete elimination. Improving the reliability of equipment and facilities begins with the elimination of anomalies, a critical activity often overlooked. While factories typically have well-designed and executed preventive maintenance plans, unfortunately, many of these plans do not include specific actions to identify and correct anomalies, simple defects, and hidden issues. This gap becomes apparent when analyzing maintenance information system databases, where anomalies lack their own category and are mixed with information on breakdowns, process issues, and requests for corrective maintenance. This lack of attention to detecting and eliminating anomalies indicates a deficiency in factory maintenance strategies. The absence of activities aimed at addressing these issues reduces the effectiveness of preventive plans, resulting in higher maintenance costs and dissatisfied customers with maintenance services. To address this situation, it is crucial to classify anomalies and establish an inspection and elimination system for these problems. The first 2 steps of autonomous maintenance are particularly relevant for addressing this issue, as they focus on actively eliminating anomalies. The first step of this anomaly elimination methodology involves creating a classification that facilitates their identification and management within elimination plans. Next, we examine the anomaly classification suggested by experts from the JIPM. Classifying anomalies is essential to establish standards that facilitate the training of operators in their detection and recording, as well as to develop improvement plans that can be implemented through campaigns. The following is a description of the categories commonly used in plants with experience in TPM. 1. Loss of basic equipment conditions. 2. Defects in the equipment that represent safety risks. 3. Minor defects or failures. 4. Equipment defects affecting product quality. 5. Sources of contamination. 6. Areas of difficult access. 7. Presence of unnecessary objects in the equipment. The following slides show illustrative examples of each of these categories. The loss of basic conditions is an anomaly that affects or hinders the fulfillment of the fundamental functions of the equipment. This anomaly manifests when the original design conditions are not respected, as well as basic cleaning, adjustment, or lubrication. Below are some examples of this type of anomaly. Absence of a belt in a transmission system, deterioration of safety signage, loss of function of the thickness gauge in a machine, contamination or dirt on a component, and absence of handles on valves, among others. This anomaly, when present, puts people's health and safety at risk, as well as affecting the environment. Some examples include loose and exposed cables, defective pipe supports, holes in plant walkways, and incomplete or poorly performed maintenance work, among others. Minor defects are anomalies that may seem insignificant at first glance, and are often not given the necessary attention. However, if left uncorrected, they can develop into serious problems for the equipment. For example, missing screws and loosening of joints, temporary fixes on an instrument panel, loss of functionality in a temperature sensor, or perforations on a surface. These anomalies have a direct impact on both the process and the quality of the manufactured product. For example, surface defects in rollers that come into contact with the product, or sensors of the equipment that have been disconnected for various reasons, preventing the acquisition of certain crucial information to ensure the variables or parameters of the production process. These anomalies can manifest as chronic leaks in the equipment, and dispersion of materials generated by the equipment itself, process, or environment, among others, which contributes to increased cleaning time and accelerated deterioration of the equipment. For example, leaks of raw materials, valve leaks, contamination from cutting residues, oil loss, particle filtrations, among others. These anomalies are equipment defects that hinder the inspection, cleaning, lubrication, adjustment, repair, and operation of the process. These difficulties complicate the proper execution of these activities, and require additional time to carry them out. For example, raised valves, excessive protections in certain parts of the equipment that require extra time for their removal, and parts with limited space to access, with the elements used for cleaning and lubrication. This final class of anomalies focuses on objects present in workshops that are not being used or are not part of the machines. Some of these objects may be correctly installed on the equipment, but due to modifications, they are no longer used or serve no function. Additionally, this anomaly also includes foreign elements that do not belong to the equipment and should not be in the area. This situation is often associated with the lack of implementation of a 5S program in the machinery. We already know the kinds of failures that commonly occur in factories and plants. In this part of the lesson, we present some practices used to record information and facilitate decision-making on how to develop improvement plans. An anomaly, regardless of the system selected for recording, should follow the following order. Type of anomaly. Example. Source of contamination. Preposition. Example. Of, to, by, in, for. Additional information about the observed issue. Example. Liquid. Preposition. Example. Of, to, by, in, for. Details about the anomaly. Example. Water dispersion. Specify the location where the anomaly occurred. Example. Filling system hose. For the example provided, the anomaly report would be as follows. Source of liquid contamination, due to water dispersion in the filling system hose. This practice is useful for accurately collecting information about the identified problem, and facilitating its subsequent study and follow-up. Operators can be trained in this practice by using photographs of the 7 types of anomalies, and conducting exercises to record each of them. In some industrial plants, similar charts to the one shown are employed to record anomalies in different sections of the machinery, where issues have been detected. Red points indicate problems requiring maintenance technician intervention, while blue ones highlight those to be addressed by operators. This visual representation enables swift identification of machine areas with the highest number of issues, streamlining improvement planning targeted at priority zones. This table aims to streamline the recording of anomalies by equipment zone and by type or category of anomaly. Presenting data in a stratified manner by type and machine zone allows for a comprehensive analysis of equipment issues, enabling more effective corrective measures through targeted anomaly elimination campaigns. The identification and elimination of anomalies must be considered as the first activity to improve the reliability of machinery in an industrial plant. These activities constitute the focus of the first phase of the autonomous maintenance pillar. In the following, we will integrate this practice in the development of Step 1 of autonomous maintenance.